Good morning, students. This is SHAFI from Don Bosco PU College, Chitradurga. In our previous class, we learned about the problems based on relations, and also we have been discussed that finding the domain and range, also codomain of a relation, and also defining a relation in a set builder form to roster form as well as in roster form to set builder form. Right, so many things we have discussed in our previous class, and also we have solved 12 questions and also we have solved in our previous class 12 questions, right? In this class also we will continue with the 13th problem. Here we have the problem that let A equals to 1 2 3 4 6, let R be the relation on the set A defined by AB such that AB belongs to the set A, B is exactly divisible by A. That means what? B, second number is exactly divisible by A. Sub questions are there. Write R in roster form, find its domain and range. It is a problem very similar to the 12th one. In our previous class, I already told you in the 12th problem itself, if you want to find out, if you want to write this one in a roster form, you find very difficult to write. If we have Cartesian product of if we have Cartesian product, then we can easily identify that which number is exactly divisible by the first number, right? If we have the Cartesian product, then we can easily write the given relation in a roster form. Now let us find out Cartesian product. Set A equals to 1 2 3 4 6. Next we have to find the Cartesian product of AA, because AB belongs to the set A. First element is belongs to the set A, second element is also belongs to the set A. Is nothing but we have to find A cross A. Once again write down A equals to 1 2 3 4 6. Kindly do not confuse. First to write the given relation in a roster form. If we have the Cartesian product, we find very easy to write in roster form, so that I am finding the Cartesian product. Without Cartesian product also we can write the roster form, but you find very difficult to write the Cartesian form. You find very difficult to write the given relation in a roster form without Cartesian product. Let us find out Cartesian product. A cross A equals to 1 1 1 2 1 3 1 4 1 6, right? There will be number of elements in the set A is 5. 1 2 3 4 5. 1 2 3 4 5. Number of elements in the set A is 5. Number of elements in the set B, number of elements in the set A is also 5. Then the number of elements in A cross A is what? 5 into 5 is 25. If we find A cross A, then we will get 25 elements. 1 1 1 1. Next 1 2 1 2. Next 1 3 1 4 1 5. Sorry, 1 6. 5 is not there. Next 2 1 2 1. Next 2 2 2 2 2 3 2 4 2 6 2 4 2 6. Next 3 1 3 1 3 2 3 3 3 4 3 6. Okay, next 4 1 4 1 4 2 4 3 4 4 4 6, right? Next 6 1 6 1 6 2 6 3 6 3, next 6 4, 6 6. It is the Cartesian product of A cross A. Based on finding the Cartesian product, we have solved so many questions, right? I hope you understand. I hope you understood the concept of writing the Cartesian product of the two sets. Now, A cross A, I told you that 5 into 5 is 25. 25 ordered pairs should be there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, right? Exactly, we have 25 elements. Now, we have to write the given relation in a roster form. First, write down the given relation. R equals to ordered pair A comma B, AB, such that A comma B is belongs to the set A, B is exactly divisible by A, okay. Now R equals to second element is exactly divisible by the first element. You just observe it. Second element is exactly divisible by the first element, right? Now 1 is divisible by 1. 1 is divisible by 1. Yes, 1 is divisible by 1. We know that every number is divisible by itself. 2 is divisible by 1. 2 is divisible by 1. Yes, 2 is divisible by 1. 1 comma 2. Next, 3 is divisible by 1. 3 by 1. 3 is divisible by 1. Yes, 1 3. Next, 4 is divisible by 1. 4 by 1. Yes, 1 4. Next, 1 6. 6 is divisible by 1. 6, second element is divisible by first element. 6 is divisible by 1. 6 by 1. Yes, it is also divisible. 1 is divisible by 2. 1 is divisible by 2. 1 by 2. Is it? No. 2 is divisible by 2. Yes, we know that every number is divisible by itself. 2 2. Right. Next, 3 is divisible by 2. 3 is divisible by 2. 3 by 2. Is it possible? No. 4 is divisible by 2. 4 by 2. 4 by 2. Yes, it is divisible. 4 by 2. I mean 2 4. Next, 6 is divisible by 2. 6 is divisible by 2. 6 by 2. 6 is divisible by 2. 6 by 2. Yes, 6 is also divisible by 2. 2 6. 2 6. Next, 1 is divisible by 3. 1 is divisible by 3. 1 by 3. No. 2 is divisible by 3. 2 by 3. No. 3 is divisible by 3. Yes. 3 is divisible by 3. Next, 4 is divisible by 3. 4 by 3. No. 6 is divisible by 3. 6 by 3. Yes. 3 6. Next, 1 is divisible by 4. 1 4. 1 by 4. No. 2 is divisible by 4. 2 by 4 is how much? 2 by 4. We will 2 by 4, the value of 2 by 4 is 1 by 2. But that should be exactly divisible. No. 3 is divisible by 4. 3 by 4. No. 4 is divisible by 4. Yes, 4 is divisible by 4. Next, 6 is divisible by 4. No, exactly it is not divisible. Next, 1 is divisible by 6. 1 by 6. No. 2 is divisible by 6. 2 is divisible by 6. 2 by 6. Then 1 by 3 will come, but it is not exactly divisible. 3 is divisible by 6. 3 by 6. 3 by 6. Then that value is 1 by 2. Exactly it is not divisible. 4 6. 4 by 6. 4 divisible by 6. No, it is not exactly divisible. 6 6. 6 by 6. 6 is divisible by 6. Yes, it is divisible by 6. Right. Hence it is a relation R in a roster form, which is the second number, which is a second element is exactly divisible by the first element. Are you understand? Very simple it is. Just I have written A cross A. By using this Cartesian product, I have written roster form. Without using Cartesian form, we can also find the roster form. but if we have the Cartesian product, we find very easy to write this Cartesian to write this roster form. Understood? Once again, 1 is divisible by 1. Yes, every number is divisible by itself. You just keep it in your mind that every number is divisible by itself. 1 1 1 1. 2 is divisible by 1. Yes, 2 is divisible by 1. 3 is divisible by 1. Yes, 3 is divisible by 1. 4 is divisible by 1. Yes. 6 is divisible by 1. Yes. 1 is divisible by 2. No. 1 by 2. No. 2 is divisible by 2. Yes. 3 is divisible by 2. 3 by 2. No. 4 is divisible by 2. 4 by 2. Yes. 6 is divisible by 2. 6 by 2. No. Yes. Yes. Sorry. 6 is divisible by 2. Yes. 1 is divisible by 3. 1 is divisible by 3. No. 2 is divisible by 3. No. 3 is divisible by 3. Yes. Written. 4 is divisible by 3. No. 3 is divisible by 6 is divisible by 3. Yes. 3 6. 1 is divisible by 4. No. 2 is divisible by 4. No. 3 exactly it is not divisible. 3 is divisible by 4. No. 4 is divisible by 4. Yes. Written. 6 is divisible by 4. Yes, but exactly it is not divisible. 1 is divisible by 6. No. 2 is divisible by 6. Yes, but it is not exactly divisible. 3 is divisible by 6. No. 4 is divisible by 6. No. 6 is divisible by 6. Yes. 6 6. Hence it is a relation R which is the second element is exactly divisible by the first element. What about the domain? What about the domain? Domain is what? The first element of the ordered pair in a relation R is called domain. Domain 1, first elements 1, 1, 1, 1, 1 we have. We should not repeat the elements in the domain 1. Next after that 2, 2, 2, 3 2s are there. We should not repeat, so that you just write 2. Next 3, 3. That means we have to write only 3, single 3. 4, 6. 4, 6. Hence it is domain. Hence it is domain. What about range? Range is nothing but what? The second element of the ordered pair in a relation R is called range. Second element 1, 2, 3, 4, 6. Next 2, 4, 6, 3, 6, 4, 6 we have. Okay. Range is also 1, 2, 3, 4, 6. That's it. Domain is what? The set of all the first elements of the ordered pair is called domain. Range is what? The set of all the second elements of the ordered pair is called range. Okay, we should not repeat the numbers in the domain and range. Hence it is the concept of relations. Understood? Kindly note down this question in your notebook. It is a 13th question. Hence it is the concept of relations. Now let us move on to the new concept in this chapter, that is called functions. Hence we have successfully finished the topic, that is relations. Now we will move on to the new one, that is called functions. What is meant by a function? First definition. A relation f from a to b is said to be a function if every element in the set A has one and only one image in the set B is called a function from a to b. This we read it as f from a to b. This we read it as f from a to b. Once again, a relation f from a to b is said to be a function if every element in the set A has one and only one image in the set B is called a function from a to b. For example, suppose we have one relation that is a relation a to b. Here we have one relation a to b, 1, 2, 3. 1, 2, 3, 6, 7, 8. 6, 7, 8. I will define one relation. 3 is related to 7, 2 is related to 8, 1 is related to 6. Is this a function? Is this a function? According to the definition, a relation f from a to b is said to be a function if every element in the set A has one and only one image in the set B is called a function. Let us verify this is a relation, this is a function or not a function. Every element in the set A has one and only one image in the set B. 1 has only one image 6. 2 has only one image 8. 3 has only one image 7. Is this a function? According to the definition, every element in the set A has one and only one image in the set B. 1 has only one image 6. 2 has only one image 8. 3 has only one image 7. Therefore, is this a function? Yes, it is a function. It is a function. Therefore, it is a function. Okay, it is a function. Let us write this one in a roster form. F equals to, relation F equals to 1 6 1 6, next 2 8 2 8, next 3 7 3 7. Therefore, it is a function, right? Let us take one more example. Second example. I will define one relation. F from A to B. F from A to B. 1, 2, 3, A, B. 1, 2, 3, A, B. Now, I will define one relation. 1 is related to A. 2 is related to B. 1 is related to A. 2 is related to B. Is this a function? Is this a function? Let us verify. Every element in the set A has one and only one image in the set B is called a function, right? 1 has only one image A, 2 has only one image B, 3 has no image. Therefore, is this a function? No, it is not a function because 3 has no image in the set B. 1 has only one image A, 2 has only one image B, but 3 don't have the image. Therefore, it is not a function. Therefore, it is not a function. Let us write this one in a roster form. Relation F equals to 1A to B. 1A to B. Right? I will give one more example based on this function. Next, third example. I will define one relation F from A to B. Relation F from A to B. A, B, C. 1, 2, 3. A is related to 1. B is related to 2. At the same time, B is also related to 3. Next, C is related to 2. Is this a function? You just think it. Is this a function? According to the definition, every element in the set A has one and only one image in the set B. Is this a function? A has only one image 1. B has two images. Image 2 and the image 3. C has only one image 2. But B has two images. According to the definition, every element in the set A has one and only one image in the set B. Then only we can say that relation is a function. Here we have the element B has two images 2 and 3. Here we have the element B has two images 2 and 3. Therefore it is not a function. Therefore it is not a function. Therefore it is not a function. Understand? Let us write this relation in a roster form. Relation F equals to A comma 1 A1, next B2 B3, B2 B3, next C2 C2. Therefore it is not a function. Why it is not a function? Because B has two images 2 and 3. B has two images 2 and 3. Therefore that's why it is not a function. Let us take one more example. Let us take one more example. Here we have one relation F from A to B, F from A to B. I will define one relation X, Y, Z, 1, 2, 3. 1, 2, 3. X is related to 2, Y is related to 2, Z is related to 2. Is this a function? Is this a function? You just recall the definition. Every element in the set A has one and only one image in the set B is called a function. X has only one image 2, Y has only one image 2, Z has only one image 2. Is this a function? Every element in the set A has one and only one image in the set B. X has only one image 2, Y has only one image 2, Z has only one image 2. Therefore, is this a function? Yes, it is a function. Therefore, it is a function. Therefore, it is a function. Let us write this in a roster form. F equals to x2, y2, z2. x2, y2, z2. I understand? So these are the examples of to verify whether it is a function or not a function. You just read the definition of a function, then you come to know about the examples, right? So it is a function. It is a definition of a function along with their examples. Okay. Now in this, note down one note point. Note down one note point. Every function, first note point, every function is a relation. Every function is a relation. We know that every function is a relation. It is a function. Yes, of course it is a relation, right? It is not a function, but it is a relation, right? It is not a function, but it is a relation. Every function is a relation, but converse is nothing but a reverse one. But converse need not be true. Converse need not be true. Okay. Every function is a relation, but converse need not be true is nothing but every function is a relation, but relation need not be a function, like that. Every function is a relation, but relation need not be a function, right? It is one note point. Next, second note point. Suppose I given examples like in the arrow diagram, right? Like the suppose the examples I given to you by using the arrow diagrams, but in your NCERT textbook they given a relation in a roster form or set Bueller form. Suppose a relation is given in a roster form. How can you identify that relation is a function or not a function? For that we have one simple point. You just note down that point. That will be very helpful to verify the given relation is a function or not a function. If the first element if the first element of the ordered pair if the first element of the ordered pair in a relation R is same, then it is not a function. Then it is not a function. It is a very simple point to verify whether the given relation is a function or not a function. This says that if the first element of the ordered pair, the first element is repeats in the relation, then we can say that that is not a function. Suppose, for example, here let us consider the previous examples. Here we have the previous examples. This point says that you just tally this point along with these examples. Suppose A1, B2, B3, C2 is there. According to this note point, if the first element repeats, if the first elements is same, then we can say that that is not a function. Here B repeated, B and B are same, therefore it is not a function. Here the first elements are not same, X, Y, Z is there. Here the first elements are not same, therefore it is a function, like that. Are you understand? Once again, first element of the ordered pair is same in the relation R, then it is not a function. If first element of the ordered pair repeats, then it is not a function, right? Based on this note point, I am going to give some examples. Note down that examples as like problems. Write down that problems in your notebook. Here we have the problem. Examine each of the following relations given below and state in each case, giving reasons whether it is a function or not. Okay, very simple thing it is. We have to verify the given relation is a function or not a function, and also we have to give the reasons. Here we have the relation R equals to 2, 1, 3, 1, 4, 2. You just remember the previous point that if the first element of the ordered pair in a relation R is same or repeats, then it is not a function. First elements 2, 3, 4 is there. Is the first element is the same, or is this first elements are repeats? No. 2, 3, 4 first elements are different. No element is repeated, no element is same, right? Therefore is this a function? Yes, it is a function. Okay, now let us define this relation in a arrow diagram. Here we have a relation R from here. The first elements 2, 3, 4 is the first element, 2, 3, 4. Next the second element 1, 1, 2 is there, 1, 2 only, 1, 2 only. 2, 3, 4 is there, 2, 3, 4. Next 1, 1, 2 is there, 1, 2. 2, 1, 2, 1. Next 3, 1, 3, 1. Next 4, 2, 4, 2. Is this a function? Is this a function? I already told you that every element in the set A, let us consider it is a set A and it is a set B. Every element in the set A has one and only one image in the set B is called a relation. 2 has only one image 1, 3 has only one image 1, 4 has only one image 2. Therefore, it is a function. Or you can remember the previous note point. I already told you, if the first element of the ordered pair repeats or same, then that is a then that is not a function. Here the first elements of the ordered pairs are different, therefore it is a function, right? Yes, let us write the reasons. 2 has only one image 1. Let us define, let us state the reasons. 2 has only one image, 1. Next, 3 has only one image 1. 3 has only one image 1. Next, 4 has only one image 2. 4 has only one image 2. Therefore, is this a function? Yes, it is a function. Therefore, it is a function. Are you understand? Okay, it is the first problem, that is called A. Next, one more example, one more problem. Second one, relation R equals to 2, 2, 2, 4, 3, 3, 4, 4. 4, 4. You just recall the previous point. If the first element of the ordered pair is the same or repeats, then that is not a function. Here first element 2 is there, right? 2 is there. Then is this a function? No, it is not a function, because first element is repeated. Or first element is the same, therefore it is not a function. Okay, let us represent this in a arrow diagram. It is a relation R. Let us call this as the set A, this as the set B. 2, 3, 4 is there. 2, 3, 4 only. We should not repeat the elements. 2, 3, 4 is there. We have to write only single 2. Next, second elements 2, 4, 3, 4. 2, 4, 2, 4, 3, 4 is nothing but 2, 3, 4 only. Okay, 2 is related to 2. 2 is related to 2. 2 is related to 4. 2 is related to 4. Next, 3 is related to 3. 3 is related to 3. Next, 4 is related to 4. 4 is related to 4. Is this a function? According to the definition of a function, every element in the set A has one and only one image in the set B. You just observe here we have the element 2. 2 has two images, 2 and 4. 2 has two images, 2 and 4. Therefore, it is not a function. 2 has two images, 2 and 4. Therefore, it is not a function. Therefore, the element 2 has two images, 2 and 4. Therefore, it is not a function. If you are getting confused, I am going to give one simple trick to verify whether it is a relation, verify whether it is a function or not a function. Suppose in the arrow diagram, if the symbol is like this, then it is a function. If the symbol is like this, then it is a function. Okay. If the symbol is like this, in the arrow diagram, then it is not a function. It is a very simple trick to verify whether the given relation is a function or not a function. If the symbol is like this, greater than. If the symbol is like this, then it is not a, then it is a function. Okay. If the symbol is like this, therefore it is not a function. It is a blind trick to verify whether the given relation is a function or not a function. Are you understand? Okay, next, third one, relation R equals to 1, 2, 2, 3, 3 comma 4, 4 comma 5, 5 comma 6, 6 comma 7. It is a question homework for you. You just verify whether it is a function or not a function. Okay, it is a question. Third question is homework for you. You just verify whether it is a function or not a function. You just remember the previous point, that what if the first element of the ordered pair repeats, then it is not a function. You just see first elements of the ordered pair 1, 2, 3, 4, 5, 6, right? The first elements of the ordered pair in this relation are different, therefore it is a function. Okay, you just write the reasons why it is a function. Okay, therefore this relation is a function because every element in the set A has only one image in the set B, therefore it is a function. It is a question homework for you, right? Okay dear students, it is the class for today. In the next class we will continue.